Welcome everybody to Devtoberfest and our session on embedding the latest from SAP HANA Cloud AI functions into your SAP BTP application. My name is Christoph Morgen. I'm product manager for SAP HANA Cloud. And TechEd is not over. In this Devtoberfest session, we will just continue on what we have explored in last week's TechEd session and deepen our insights on the latest of SAP HANA's AI function. So I want to give you a brief refresher on what are these AI functions for those who are new to the topic, and then go into a latest update, show you a demo, and then move over to some of the roadmap items and also showcase how you can embed your AI function calls into your BTP or CAP application code. So let's get started now. Refresher on SAP HANA Cloud AI capabilities. So we speak of capabilities for building embedded AI application. We refer to that as classic AI scenarios. For example, we speak of classification if we want to predict a categorical value based on our structured features from a table in SAP HANA. We want to predict if a customer is likely to churn depending on the customer attributes, or if a transaction is fraudulent or not, or if a customer is likely to buy a product or not. In contrast, we are speaking of regression if we are predicting a numerical continuous feature like a price, a cost, etc. Again, based on features, or in this case, car prices, on model characteristics or market trends, data we have available in our HANA Cloud database table. Clustering would be if we want to detect unknown groupings of our data like customer groups. And we speak of time series forecasting if, in contrast to regression, we not only want to predict a single numerical value, but a continuous series with a time relation or time horizon into the future. Then we speak of time series forecasting, like predicting future sales, predicting future demand, costs, and figures like that. Time series forecasting is also the most widely adopted scenario for all the classic AI functions on HANA Cloud. So that's very common. Almost 1,000 instances of HANA Cloud are running these functions. Text processing has been a use case which has experienced a revival alongside with the new text vectorization capabilities using the vector engine. We're starting again to do more with text data stored in SAP HANA. Now looking at our capabilities, our out-of-the-box function libraries for building these embedded AI applications. We have the automated predictive library, function library, more targeted for the non-expert, for the classic developer with a simple SQL interface for scenarios like classification, regression, time series, where the function itself takes away all the constraints on its usage from the actual user. So you don't need to think about which data can I pass into this algorithm, for example. The other library is the Predictive Analysis Library, our expert library with over 100 trending functions, trending in the sense of AI functions in the overall domain, the open source library. So we have gradient boosting, profit for forecasting, isolation forest for outlier, etc. Deep neural network functions, also for classification and regression, time series, etc. So lots of functions in there. We will get an overview in a second. You can use all of them from SQL as well as from more the expert languages, scripting languages like R and Python. We will look into how to integrate those function calls into our application code. And one thing I'd like to specifically highlight is that with the Predictive Analysis Library, we have seen a tremendous and continuous stream of innovations over the last 3 years since its launch of HANA Cloud, over almost 80 innovations in these 3 years. The AutoML interface for classification, regression, and time series is a key. Enhancements where we have introduced, and lately also the support of vector processing with those AI functions, where we'll see more innovations coming along in the next couple of quarters as well. As I said, the automated predictive library targeted for the non-expert with the simple SQL function interface, and also, as I mentioned, it takes away the burden of thinking about which features may I put into the functions and which maybe I shouldn't. Variable selection, data preparation, encoding of values, all that is handled automatically, and it's a quick and easy, fast forward approach for building models, fast time to value for everybody, including the non-expert. So try it out if you are getting started with machine learning or these classic scenarios on HANA Cloud. The Predictive Analysis Library, our expert library. In addition to what I already outlined, we have fast inference capabilities. We are providing stateful models. We'll talk about segmented modeling also in another example, and also the demo. I've overviewed the AutoML engine capability already, and responsible AI implementations providing ML explainability around the models, but also with respect to the predicted value. Predicted values is one of the key also assets we provide out of the box with our Predictive Analysis Library. Here now you get an overview about the richness of the Predictive Analysis Library and its functions. Over 100 functions. We kind of stopped counting all the algorithms we do provide. By the color scheme, you can basically see which are the new or enhanced functions only available with SAP HANA Cloud. To name some, segmentation for AutoML on the lower left side, multitasks, multi-layer perceptron, fair ML, enhancements in outlier detection for regression, several time series analysis algorithms and enhancements. They are only available in SAP HANA Cloud, and more. So a rich set of algorithms. And what did I say? Why do we have this AutoML interface? Even for experts, sometimes it's a challenge and a productivity kind of burden if you want to try multiple algorithms in regression, for example, to come up with the best possible model. And this is where the AutoML interface helps, where we can basically say, I want to build a regression model. Please try out all these algorithms with a given, let's say, parameter set or parameter space to try out. So it's an optimization task to find the best model. And that's where the AutoML interface helps even the experts to come up with the best possible model in the shortest time period. And we will see that also live in a second. As mentioned, for those who are new to our capabilities, we have these Python interfaces, and we will see that in the demo. The Python machine learning client, as it's called, which allows scripting in Python, but actually SQL is generated on the fly as we use it. We have a concept of the HANA data frame, which is a Python virtual data reference to data in HANA. Basically, behind the HANA data frame in Python, there's just a SQL statement as a query against the HANA system. It can be against a table, a calculation view, whatsoever. Everything we can query in HANA can be behind the HANA data frame. There are some spatial and graph capabilities also available, and both the Predictive Analysis Library and the Automated Predictive Library can be used. This is an example of how, for example, a random decision tree classifier would be used in the Python machine learning client. And the whole idea is that for data scientists who are new to the SAP world, it is a very fast-forward approach to pivot, for example, from scikit-learn as an open source library to what we provide for HANA. So all the parameters, we try to keep them aligned with what is common in the open source world. So it should be a pretty straightforward approach to try out our HANA unified classification random forest algorithm compared to maybe what people have been doing before with open source packages. And certainly, as I mentioned, there's always a SQL interface to all the algorithms, like sticking to the example, the classification example. We have a SQL procedure, PAL unified classification, where we can just pass in our data and the parameters need to be provided in a table, and then we can simply execute that. And as it's SQL based, we can certainly embed this into all our application. That's straightforward. For ABAP, for example, you would be using the ABAP managed database procedure. And then we have the HANA design time artifact HDB procedures, which we can use in addition in the other application development environments, including the CAP application on BTP. So what are the latest enhancements, or some of the latest enhancements I'd like to showcase here? In the Q2 release of SAP HANA Cloud in 2024, we released a new so-called multitask multi-layer perceptron function. It's a neural network-based algorithm, a trending implementation, which basically provides to model not just a single target column, but multiple target column which we'd like to predict at once. So one complex neural network with multiple neural network algorithms and architectures behind the scene, which can be used again. And the key and the nice thing is that as we have multiple target columns, the neural network architecture is able to capture common information or common feature across target, as well as the ability to select prediction target specific information as part of the model. So it provides best performance and generalization for the task of predicting these multiple targets with a single model, and certainly best performance and outcome as we would expect it. So it's a modernization of the previously also available multi-layer perceptron algorithm. But the key benefit is really from a use case perspective, and we have had engagement with stakeholders and customers that they want to predict multiple target fields in one go. For example, like sales order automation, where we'd like to provide proposals for multiple of the fields of an order form within an application at once using a single model and with respective correlated information as part of the single model. You can see it here on the right hand side. So the SQL function is called PAL MLP multitask predict. So that's basically the new function, and in the lower right section you would see that we predicted target score 1, target score 2, 3, and so on. There's a detailed blog here also linked, which we published in June, which explains the new algorithm in detail. Then an enhancement in the Q3 release, which is also a great, let's say, enhancement of the existing AutoML capability, which now takes the AutoML approach, which I talked about before. So we have, let's say, 15 time series analysis, time series forecasting algorithm. We want to apply that to our data, but we don't know which is the best fitting algorithm for our given time series data. So AutoML helps with finding that out. But now we want to take that to the next level, as this is a very, very common pattern with all our time series forecasting stakeholders, that there's not just a single time series in our data, but we structure our input data by a grouping column that could be like stores or locations or product store location combinations, and for each product we would have a, let's say, a sales or demand time series, and we would like to model individual time series models in a sense in parallel for each of the, let's say, group IDs. And in applications like integrated business planning, this parallelization or this effort of training multiple time series model at once or in a series has the dimension of tens of thousands up to hundreds of thousand time series. And with this so-called massive function we provide for the predictive analysis library, such a time series analysis or forecasting task can be parallelized internally in a very performant fashion. And we're now taking this massive or segmented or data parallel invocation of our functions also to the world of AutoML with the predictive analysis library, and we'll see that in a second. Or also already here on the screen we have some product time series data for different products, new shampoo and classic shampoo, and we want to parallelize our time series analysis task to find the best model in parallel for the two product groups. And as we can see in the output of that screenshot, and we'll see that in the demo in a second as well live, the model or the training task will find different best possible algorithms for the different time series, the classic shampoo or the new shampoo. So a great enhancement, also providing this data parallelization for AutoML tasks as well. And then another highlight in the current release is the ability to process vector data with our predictive analysis function library algorithm. And the first area of PAL functions which provides this capability is in the clustering area. We have the density-based clustering algorithms called dbScan, and a new flavor which is called hierarchical density-based clustering, which are enabled to process vector data, and with that we can detect unknown groupings from, let's say, our vector data space. In this case we may have vectorized, for example, text describing movies. I think that is a common scenario we have been using, or in this case here we use for the demo of the screenshots, this is product descriptions. So we would be cluster the actual vector data behind the product descriptions, and from that find these unknown clusters within our product categories from our vectorized data, extracting the semantic meaning from the product descriptions, and therefore maybe detecting new or more fine-grained clusters in our data. Hierarchical dbScan has the advantage that it can detect clusters of varying density, so that's an advantage over the classic dbScan algorithm, and therefore is more robust and provides better results than dbScan. And with that, let's look at the demo. I go into Business Application Studio, and we'll also provide this demo notebook for you as well. A flavor of it is already available in our subsamples, HANA ML samples repo, where we, with every quarter, provide an example with all the new feature or the most of the new features. I'm using a subset of this for this demo. What is new, what I'd like to outline in general this quarter is that the predictive analysis library capabilities are now also available with the trial and free tier instances of HANA Cloud. During the configuration and the setup and the advanced properties, you can now simply select PAL, and then these functions will become available. All right, and that's what I will be doing. I'm using my trial instance, loading the Python machine learning client, the package HANA ML, which can simply be pip installed from the open repository of PyPy. So you can see it here. I've done that before. And then what I'm using for storing my credentials, I've in my Business Application Studio environment pre-installed the HANA client, and I'm using the HTTP client user store to store my credentials. There's some guidance here, which is also linked in this notebook, what you specifically need to do. To then locate my user store, and here I have my connection key defined to my HANA Cloud trial instance. So I'm now connected. It's a Q3 instance. We see that from the version I'm using. And one of the new features is just reuse of the connection string if you're using SQL Alchemy. And maybe a couple of you are familiar with SQL Alchemy and Python scripters, so that will be a nice feature. Just like to very briefly highlight here. But now we're coming to one example we have also seen in the TechEd keynote. The use case is we want to predict sales refunds on a daily basis. So we have a time series of daily sales refund figures, and we'll see that in a second. We'll structure our data, maybe what we can simply do here, do a small code exit. And have a look into the data, the actual data, and so I'm using the data frame which I've created, HDF. That's the HANA data frame, which is created here from this method, create data frame from pandas. I've loaded the CSV file, put it directly into HANA table, specified the structure of the table in HANA, and then created this data frame HDF, and it can then use methods to look into the data. And this is simply issuing a SQL statement, top 10, select from the table, collect basically instructs the Python environment to capture the data and move it over into the Python environment. Otherwise, the idea is for the HANA data frame, all the data stays where it is on the side of the HANA database. So I'm creating new data frames here. CC is the connection I've defined. So I say create a data frame against a table. I could simply also reuse what I already have, but just for the purpose of illustrating how we would be working with data frames, creating this new refunds data frame. And then I'm using different filters to have kind of a cutoff date for training my model and testing the forecast model. Let's do that. And next step is actually to build a forecast model. I want to use a popular forecasting algorithm called Profit, which allows me to detect change points, to detect different seasonalities, to automatically infuse it with external information like holidays and other data. All that can be done. It's a very robust, fast, and trending algorithm if you want. So that's what we will be using for modeling the time series. So the algorithm in the Predictive Analysis Library is called Additive Model Forecast. And I'm then, once I've defined the object, fit the forecast model and then predict it on my test data. And certainly I then also want to visualize the algorithm. That should look familiar to you if you saw the TechEdge keynote. So that's what we are doing, and actually the algorithm, the model looks quite nice, seems to be fitting here. Then there's certainly also methods to calculate the accuracy of the forecast. For that, we are bringing together the actuals and the predicted data, and then use the TSA time series analysis forecast accuracy methods to evaluate how good from a statistical standpoint our forecast model would be. Mean average percentage error, for example, would be something we're looking into. Whatever, there's different measures for different use cases helping us to qualify that. But that seems to be not too bad, this forecast model. Okay, but we are developers, or you are developers. Certainly what we'd like to do is infuse the SQL code into our HANA application on BTP. One thing we can do here is look at the executed code behind the scenes. We can always capture that from the HANA client side, but there's also methods here, base methods for every algorithm in the Python machine learning client to capture the SQL code. So we can do that. And let's go into the SQL console here for my trial instance. And I can now simply execute the code. And that's basically what happened behind the scenes. I think if I run it again, I should be getting an error because we are saving here the data into a temporary table and that already exists. So it's all live. If I now do this again, this should be working as expected. And if I go over here and say now I'd like to, in contrast, look at the predict statement. So we want to do the prediction part also using here our SQL code. We can do the same. We still have the model table available in our session. So we're selecting the data here and we're passing in the model table. So that's the temporary table that should still exist. So with that, we are getting the results, and certainly we can also do that in a different fashion and say in parallel, just let's get the output also displayed here, executing this again. Incorrect syntax, or maybe that was too fast. Yeah, see, I missed this little friend here. And now we would be seeing the forecasting results. So what happens basically, as I mentioned, as we are scripting in Python, we're generating SQL on the fly, and certainly we can also capture that to embed the code into our application. But we want to do that in a more, let's say, aided and supported way for the developer, directly generating the design time artifacts. And for that, we introduced a while ago a class of design time code generators for HANA, and specifically with some enhancements for CAP applications. If you're targeting CAP application, and we'll see that in a second. Let me create a new directory where we are generating the artifacts into. We can give the project a name, specifying a directory here where we want to have the objects generated to. And we see in our project directory, there's a new subpath with all the artifacts we had here generated. What we see here, that we have a series of procedures generated, and grants and synonyms, or everything you basically need for for embedding that code into HANA database or SAP application project. We have the fit procedures. As we can see here, there's always a base procedure and a consumption procedure. The idea between those is the base procedure contains the parameterization with respect to the actual algorithm, whereas the consumption feature is then mapping that to the actual input data or output structure you'd like to use. If you look at the predict object here, for example, the consumption object is basically calling the base object, but we are only specifying input and output, and the consumption therefore could also be a table function. So that's basically the same consumption code if we want, but just a different object. So we can pass this into a calculation view, for example, as well, or simply call the prediction on the fly by querying the table function. However, as this is a CAP project, we also have generated the CDS artifacts for the output tables we would be needing. We have specified the namespace during our generation, and what we have also done is here in the service subdirectory we have created the service definitions here for the output objects as well. So think great capabilities for US developers should be helping with the fast forward to integrate those machine learning capabilities into your project. We have more information on that. It's something we have released last year, and mapping that again to what we have seen in the TechEd keynote demo. What we want to do is overlaying this with a generative AI assistant, which basically helps us with the overall process to a simplification level where we can say, hey, this is my data. I'd like to train a profit model, time series forecasting model on this scenario, and please generate me these design time artifacts. We will provide some standard capabilities there, but you will always be allowed to infuse your best practice code examples. So the generated code basically maps to what you would want to be using as your standards in your organization, in your company, and use that for the more customized, targeted code generation. All right, so let's look at some of the new features I already talked about in the slides. For that, I'm running not against my trial instance, but against another productive instance, because the trial landscape capability has a delay of a couple of weeks with respect to the new PAL functions and features to be available. So in the current release of the trial landscape, we would see the functions released in Q2, but not necessarily already all of the Q3 PAL function capabilities. I overviewed the AutoML enhancements with this data parallel or massive AutoML TimeSeries modeling, and we want to now take a look at this live. So we see here our data. I again loaded the data from a CSV file, created a data frame shampoo HDF looking into the data frame, we see we have different products in there, and we have continuous series of sales numbers, monthly sales numbers for our products. And now we use from the AutoML class, we use the massive AutoML class, and massive again implies this data parallel invocation. We give for the time series AutoML search here, a couple of parameters for the genetic algorithm. Maybe we don't want to have 30 generations, but only 3 in this case, and maybe only population size of 15 to have kind of smaller round trip for us as we're doing the demo live. And the key parameter here we need to specify is that we specify the product as our group ID for the parallelization. And now let's get this running, and I think it should not take too long. As we can see here, 6 seconds, and what is now the result, or what was executed. Maybe just to stick to that, as we use this method to again inspect what has happened. I need to enlarge this. We would see PAL massive AutoML fit. This is what just was executed. Let's look at the result, the model, and the pipelines. There's the so-called best pipeline object where we can inspect the best pipelines. In this case, the best pipelines for classic shampoo and new shampoo. Get the output there. And let me look at my code. All right. And so we see for the new shampoo, we have a different best algorithm, Bayesian structural time series, as for the classic shampoo, where we have an auto exponential smoothing algorithm being used. We can then apply basically both using the predict function and predicting into the future for both classic and new shampoo in our demo scenario. So that's basically the new approach, and I think it's great enhancements of AutoML and bringing AutoML for time series specifically to this pattern, which is most commonly used by all our time series stakeholders on SAP HANA Cloud, invoking the algorithms in a data parallel fashion to large amounts of time series data. Second new feature, which I'd like to just briefly show to complete the picture, is that multi-layer perceptron, in the use case here of the multi-label classifier MLP. So I have some data, which is our diabetes classification data, and in addition to what we've seen before, let's do that again. Look into the actual data frame here. Come on. Let's look at the first 10 columns, rows. So you get an idea what the data looks like. So we have diabetes and PNP, which is the second disease we want to predict. It's a peripheral neuropathy, we call it. So it's some nerval disease which typically goes along with some of the diabetes patients as well. We do some data splitting into train and test, so we can again observe the quality of our trained models on data we didn't use for the training of the data. That's why we use this partition function, using the multitask classifier now as the object. Our targets or target labels are diabetes and PNP. That's what we specify. There's all kinds of neural network parameters we could specify. I'm keeping it simple here. And now let's train the neural network model. There's certain objects we can use to inspect what the model looks like, the parameters, the iterations, when we found the best model, etc. All that can be found, but let's keep it simple to the fact that we have trained the model, and we can then certainly also predict using the model on our test data. And as we can see here now, and that's the point of the prediction, we not only get predictions for ID4 for diabetes, but also for the neuropathy as the second target label. And again, we can certainly use the cup generator approach here. For that, maybe just as a note, if we do the design time code generation, the scenario typically doesn't work if the training data and the model table are local temporary tables. So we need some consistency here of the artifacts we are working with. That's why we are saving the model and passing in the model table to the algorithm. We are saving the training set, just again to make sure we have kind of a static and not a, let's say, a temporary table which we're passing in. And let's do that quickly. And once it's finished, we can again call and use the cup generators, and yeah, just for the point of illustrating, we're really creating new artifacts for this project. And as we see here, come on. Okay, something went wrong. Okay, I didn't see that, and it's again exactly the point with the model table. So I was too much focused on looking at the results. So I need to find out with. I think in the example I will be providing here for you, this issue will be fixed. So look up in the HANA ML sample. I will paste where it's in the chat. This issue will be resolved and should be working for everybody. Okay, and that's it with my demonstration. I have some slides to finish up the session. And yeah, certainly we also wanted to look ahead. So let's start with that. Look at the roadmap, what's coming. We also already talked about in our TechEd session, but just to refresh you, to enhance the scenario about using the HANA vector engine, where in the past the embedding vectors, or still today until we have released this in database text embedding function, the vectors needs to be calculated and generate outside of the database. Certainly if your text data is already in the system, that's kind of an unnecessary round trip. Therefore, we will release this in database text vectorization function, where you can then explicitly call, use the text column, transform into the embedding vector column, or even design the table in a way that on update new text or on insert new text will be automatically transcoded into the text vector and the vector column. Moreover, we will address a gap between the on-premise and the HANA Cloud release regarding text analysis functions. So we will introduce those for common scenarios like entity extraction or sentiment detection. And I think one of the highlights will be in that release broadening the scenarios where we can use vector data with our classic AI functions will be the support of vector data for classification and regression functions. So basically, if we have, for example, a service ticket application where we store the ticket text information in our database table. In the past, we tried to use simple classification algorithms on maybe keywords or terms we had extracted from the text column, or just use the other features as part of the column. And these approaches always lacked that we couldn't extract the semantic meaning of the terms for the classification or regression task. And now with the ability to use the text vectors as input features to our classification and regression algorithm, we can now use the vectors along with all the other structural, categorical, numerical attributes to build this new class of classification and regression models in HANA Cloud. This will be a great enhancement and unlock many new use cases. Then what we have seen in the keynote demo and what I've talked about is how can we generative AI enable the use of our Python machine learning client and the HANA AI functions with this new generative AI toolkit. We want to provide a Python package first and foremost, which can be used to generate these time series forecasting, classification, regression scenarios based on standard samples we provide, but you can also provide and extend your own custom samples for your more targeted code using the HANA Cloud vector engine behind the scenes. The text embedding functions will certainly be used, but there's always the option to use what is available via Generative AI Hub, as well as we will be using the large language models to via Generative AI Hub to generate the respective code. At a later point in time, we also seek to integrate this into sub-build code for the full pro code experience, as we saw it at TechEd in the keynote. And just as a refresher on the whole topic of design time code generation for intelligent data application, whatever you want to call your BTP application, where you leverage more of the HANA native capabilities. We had at the Recap conference last year a nice talk and demo which went into the details. There's a blog available, auto generation HANA ML Cup artifact from Python, which goes into details. And we just saw that a way to generate the SQL design time artifacts. And with the cup generator, as I showcased in the demo, we in addition would be generating the CDS related artifacts. There's some manual steps still need to be done as of today, at least, regarding the procedures where we need to create the Node.js function interfaces to map those then into the application. So what you see here in the sample application, which I'll also show you in our sample repository in a moment, where we see predict the price and train the model. It's basically the functions, the procedures, so the HANA procedures, which are made available via the function interfaces and mapped into here the application UI. So triggering the predictions, triggering the model training. That's how this is integrated into the CUP application. Yeah, we saw the demo of the code generation as well. And with that, basically let's go into Q&A, we have the YouTube chat. I'll just start now looking at all your questions, and yeah, I'm happy to answer all your questions in the chat, or you can certainly also reach out directly to me. We saw kind of that quick overview of making use of the AI functions libraries in HANA, the latest enhancements, which we provided with some new function examples in the Q2, Q3 release, how we can do the code generation. And yeah, I hope this was a good and appropriate overview on the latest updates and look into the future, what we will be providing from the HANA AI side for you as application developers on BTP. Yeah, thanks a lot, and yeah, see you in the chat. Bye bye for now.